Hi everybody. In this tutorial we're going to cover how to deploy a contract on Oasis Sapphire. So Sapphire is a confidential EVM and it runs inside a trusted execution environment, which means all the contracts have confidential storage and all the transactions are encrypted, meaning everything between the user and the smart contract is end-to-end encrypted between their browser and the contract. So unless you explicitly make something public or omit an event with the information, then everything will remain confidential when using the appropriate plugins. So let's start by creating a new project. As you can see, I have Visual Studio Code open and a Linux terminal. If you're using Mac OS or Windows, the commands will be roughly the same, but on Windows, there will be more differences. I usually use pnpm as it's a little bit faster than npm or yarn, so let's create a new project. And we're going to need some dependencies for our project. So we're going to use TypeScript. So let's start adding dev dependencies. So we want a TypeScript and TS node. Then, because we're using hard hat, we're going to want ethers and hard hat. And to make things a little bit easier, let's add the hard hat toolbox. Used by Nomic Foundation. And then we're going to want the hard hat plugin for Sapphire, which ties everything together and automatically encrypts your transactions. So this will take a minute or so to run through. And that's our dependencies installed. So next, because we're going to use a TypeScript, we're going to have to set up a tsconfig JSON file. And I'm going to copy in the config that I generally use on projects. And next, we're going to create the hard hat config file. So it's important to start with the Sapphire hard hat plugin and make sure that goes first. And then we're going to import the hard hat user config definition and the hard hat toolbox. So to start with, we need to define our accounts. So I'm going to use the test HT wallet, but we can override this using the private key environment variable. And if it's not specified, it will use the test HT wallet. So let's create our outline for the config and make sure that's exported. And then we're going to define which version of Solidity we want to use. So Solidity, let's use version 0.8.19. Specify some settings. And when compiling, we want to enable the optimizer. Then for the networks, I'm just going to copy in the hard hat network along with the definitions for Sapphire, the Sapphire testnet, and a local instance of Sapphire. So now that's done, let's try to create some contracts. So we're going to start with a very simple contract. If you're going to open source it, you probably want to add the license identifier to it. And then let's use solidity 0.8 or above. And it's not doing anything at all at the moment. So that's our IRMT contract. But next we need something to deploy it with. So let's see if that compiles. That's great. So it's generated the type chain types for that, which allows type hinting for your contracts in TypeScript. And it's built the artifacts. So let's write a deployment task. Let's go to the tasks directory, create our deployed.ts file. And in here, let's import task from hardhat config, and then import our hardhat runtime from hardhat types, and then start defining our task. So we're going to have to get the contract factory. We're going to need to get the HRE runtime environment. So let's add some args here. And via HRE, we can access all of hardhat's accessories. And because we've got the TypeScript types generated, it fills that in with what's available. So we've got a contract factory. Then let's try to get a version of our contract deployed. So and we're going to want to know what the deployment transaction is. So and output the transaction hash for this. Then we're going to want to wait for the contract to actually be deployed. So in order to be able to run the deploy task, we need to add this into our hardhat config. So right at the top here, let's do import tasks deploy. We go into the console here, so we do pnpm hardhat deploy. Make sure that's picked it up. And you can see our help message here. So let's try to run this against the local hardhat node. And you see deployment transaction, that, but we need to output the address that it's been deployed to. So let's do console.log contract. Run this again. And there we go. It's output our contract address. But to be able to deploy this onto the Sapphire testnet, we're probably going to need some tokens on our account. So I'm using my test account here. And I've already got some tokens, but if you need some testnet tokens, you can go to the faucet, which is at faucet.testnet.oasis.dev, and select Sapphire from the dropdown. Let's copy in our address here. verify that you're not a robot, and click the Request Tokens button. And in a few minutes, some tokens will be dropped into your account. So next, let's have a go at deploying this onto testnet. And it will take a little while for the transaction to be submitted and to be confirmed. And we've got our deployment transaction and the contract address. So if we go into the Sapphire Testnet Explorer, into the transaction ID, and you can see it's been created. If we look at the contract address, while the code hasn't been verified, you can verify it through Sourcify. But you might not always want to deploy it onto testnet. So for this reason, I'm going to start a local instance of Sapphire. That can be started with the Sapphire dev container. And it's going to take about a minute to start up, but that's because it's running a full version of the Web3 RPC gateway for Oasis, along with the consensus beacon and a couple of nodes. So this allows you to deploy your contracts locally and to use all of the features of Sapphire. So as we can see, our Sapphire node has started up, and we have the usual testnet wallets pre-funded with tokens. And it's accessible by localhost, so you can use that with your MetaMask plugin and through Hardhat locally. So if we go back into our terminal here, let's try to deploy it locally. And you see that's run a lot quicker. So the block times on the local testnet are much quicker, and that will speed up testing for you. So let's add some Sapphire specific functionality to our contract and write some tests. So if we go back into our contract, now what's available on Sapphire? So the functionality on Sapphire that's not available on other chains are the Sapphire specific precompiles. So in order to access them, you need to add the Sapphire contracts library. So let's add the Sapphire contracts library. There we go. So back in our contract, let's copy this in. And I think let's start off by generating a secret that's only visible by the contract. So if we do a -32, private, secret, and any variables on your contract that are marked private or internal will not be accessible, but But if you make them public, then anybody will be able to call the contract and retrieve the value. So let's do our secret, bytes 32, sapphire.random bytes 32. So if we go and compile that, and you can see that if we deploy this, it won't work if it's running on the local Sapphire network. So while the constructor did perform this, the random bytes didn't return actual random bytes, but it's useful for testing. So if we create an accessor method, so we get secrets, and let's call it string password. So we're going to require a password to retrieve the secret. Let's make this public. Let's make it a view call, and then returns bytes 32. Be our secret. So if we hash the password and check if it's the password that we want to set. So let's turn that into require. So we're going to require that the password matches password with an exclamation mark. If it's correct, it will return our secret. Now, let's create some tests for this so we can verify if this works. So create a test directory. And we create a test where it works. So again, we need to get our contract factory. We need to import HRE. We're getting our test contract factory. Deploy the contract. And then wait for it to be deployed. Let's clean up the weights. So now we have an instance of our contract. Let's see what happens if we give it the correct password. So every time that you update your Solidity file, you're going to have to recompile the hard hat contract to update the typings. So let's give it the correct password and output the secret. And let's run this through the hard hat tests on the local network. You can see it generates a secret, and giving it the correct password returns the secret. And every time the contract's created, because we're using the Sapphire VRF, it's generating a random secret every time. And we can then check what happens if we give it the wrong secret. We run the test. There we go, and it's reverting. We go and put an error message in here. Run this again. You should see the error message come back from the contract. There we go, wrong password. And likewise, you can deploy this onto the testnet and run the tests against testnet, although it will take a little bit longer. And we'll be able to see our transactions pop up in here. Although sometimes there can be intermittent failures. But if that happens, just rerun the test. And you can see so if we remove the error from here and deploy this again,